Further to finding the gradient for a given line, we need to be aware that there's two forms of a straight line that we're commonly going to encounter. The first one's called the gradient intercept form, and this takes on the general form of a line, of an equation for a straight line, that looks like this. Y equals mx plus b, where the m stands for the gradient of the line and the b is the y-intercept of the line. The next most common form of the equation of a straight line is called the general form of a straight line, and it takes on the form ax plus by plus c equals 0. Now from these two equations we can find out the gradient. You can see very clearly that in the first example of the gradient intercept form, the gradient is given within the equation of a straight line. For the general formula for a straight line, it's a little less obvious how we're going to find out the gradient, but the way we do this is by making y the subject of the formula. And I'm just going to work through this equation and make y the subject of the formula so that you'll be able to see that it's in the same form as the gradient intercept form, and you'll also see how it is that we find the gradient. We start off with ax plus by plus c equals 0. Now I'm going to remove everything that is not a y term over to the right hand side of the equal sign. By is equal to minus ax minus c. Now to find out what just y is going to equal, then I'll divide through by b, which gives me the equation y is equal to minus a on b x minus c on b. And quite clearly you can see that this equation is now in a similar format, or is in the same format as the gradient intercept form, and where we had the gradient given in our original equation of the gradient intercept form, we see we've got the expression minus a over b. So in fact, minus a over b is the gradient of the equation of a straight line that's in the general formula.